Let us look at Arithmetico-Geometric Series. What is that? We know an arithmetic progression is a, comma a plus d, comma a plus 2d, a plus 3d, and so on up to the nth term, that is a plus n minus 1d. Now, multiplying each term with successive integral powers of r starting from r to the power of 0, we get r to the power of 0 times a, r to the power of 1 times a plus d, r square times a plus 2d, r cube times a plus 3d, and so on, so that the nth term becomes r to the power of n minus 1 times a plus n minus 1d. Now, why we end up with n minus 1 as the power of r is because we are starting from 0. This is called the arithmetico-geometric progression. Now, we have to figure out how to get the sum of first n terms of this series. And then we will look at for the infinite series of this. So S sub n is equal to the sum of all these terms. Now we multiply S sub n with minus r throughout. We get minus r times S sub n is equal to minus r times a minus r square times a plus d minus r cube times a plus 2d minus r to the power of 4 times a plus 3d minus, and so on. The second last term becomes minus r to the power of n minus 1 times a plus n minus 2d minus the last term r to the power of n times a plus n minus 1d. Now we add up these. So when we add these two, the first term will be a. Now here what we are doing is we are shifting this entire series to the right by one term before we add. So first term is a, second term will be r times a plus d minus r times a. We get ar plus rd minus ar, which gives us dr. The third term becomes r square times a plus 2d minus r square times a plus d, which gives us ar square plus 2dr square minus ar square minus dr square. Ar square gets cancelled. We have 2dr square minus dr square, which gives us dr square. And if we continue to do that, the n minus 1th term will be r to the power of n minus 1 will be common, and we have a plus n minus 1d minus a plus n minus 2d. Nth term will be as it is. Let's combine all of these. We have s sub n minus r times s sub n is equal to a plus dr square dot 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 dr to the power of n minus 1 minus the last term r to the power of n times a plus n minus 1d. Let's simplify this. We get Sn is common, so we take it out. S sub n times 1 minus r equal to the right hand side. Here in the right hand side, we have dr common to all these terms. So we take it out. We have dr times 1 plus r square plus dot 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 r to the power of n minus 2. S sub n times 1 minus r is equal to a plus dr times, and this is a finite geometric series, and we know the formula for that. So dr times 1 minus r to the power of n minus 1 by 1 minus r minus this term as it is, a plus n minus 1 times d times r to the power of n. 1 minus r, we take it to the other side. So we have s sub n is equal to a by 1 minus r plus dr times 1 minus r to the power of n minus 1 divided by 1 minus r square. Because 1 minus r comes from there also, and there is already 1 minus r. Minus a plus n minus 1 times d times r to the power of n divided by 1 minus r. So this is the sum of first n terms in this series. Now let's look at sum to infinity. Remember, if the magnitude of r is less than 1, that is r is between minus 1 and 1, the series converges. When n goes to infinity, we have r to the power of n minus 1 going to 0 and r to the power of n going to 0. So the second term, dr times 1 minus r to the power of n minus 1 by 1 minus r square goes to dr times r to the power of n minus 1 has gone to 0. So 1 by 1 minus r square. And the third term, what happens? That goes to 0. Why? Because we have r to the power of n, which also goes to 0. So this whole thing becomes 0. In the formula, the third term becomes 0, and in the second term, 1 minus r to the power of n minus 1 becomes 1. So our formula for the sum to infinity is equal to a by 1 minus r plus d times r by 1 minus r square. And we already have this formula. Using this formula, let's solve an example. So we have s sub infinity is equal to 1 plus 3x plus 5x square plus 7x cube plus and so on. It goes on up to infinite number of terms. Now here, what is a? A is 1. What is d? D is the common difference in the arithmetic part of the progression. So we have 1, 3, 5, 7. So the common difference is 2. And what is R? The common ratio of the geometric series part of it. We have x to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3, and so on. So x is R. So a equal to 1, r equal to x, and d equal to 2. So let's apply this formula for the sum of n terms. First n terms. We have a by 1 minus r. A is 1. So 1 by 1 minus r is x. So 1 by 1 minus x. Plus dr. dr, that is 2x times 1 minus r is x. So x to the power of n minus 1 divided by 1 minus x square minus 1 plus n minus 1 times 2 times x to the power of n divided by 1 minus x. Simplifying that, we get 1 by 1 minus x plus 2x times 1 minus x to the power of n minus 1 by 1 minus x square minus x to the power of n times 2n minus 2 plus 1, which gives us x to the power of n times 2n minus 1 by 1 minus x. This is the formula for the sum of first n terms. For this series, if the absolute value of x is less than 1, then s sub infinity or sum to infinity is equal to, we apply this formula, 1 by 1 minus x plus 2x by 1 minus x square. And remember, for absolute value of x greater than 1, the series diverges. So there's no question of sum to infinity. For absolute value of x less than 1, the series converges as we have seen here. For x equal to 1, the series reduces to an arithmetic series and hence diverges. For x equal to -1, the series oscillates between negative and positive terms and hence does not converge. But now, let's actually verify whether this formula actually work by at least figuring out whether sum of 1 equal to 1 and sum of 2, or rather sum of first two terms is 1 plus 3x. So we have s sub 1 is equal to 1 by 1 minus x plus 2x times 1 minus x to the power of 1 minus 1 by 1 minus x square minus x to the power of 1 times 2 minus 1 by 1 minus x. So I have basically substituted the value of n as 1. Now 1 by 1 minus x plus this, what happens? Here x to the power of 1 minus 1 is x to the power of 0. Anything to the power of 0 is 1. 1 minus 1 is 0. So which means the second term disappears. And we have 2 minus 1, 1. So x by 1 minus x. Denominators are same. So we can directly say 1 minus x by 1 minus x. Cancelling these two, we get 1. And it is 1. Now let's try for two terms. S sub 2 is equal to 1 by 1 minus x plus 2x times 1 minus x to the power of 2 minus 1 divided by 1 minus x square minus x square times 2 times 2, that is 4 minus 1 by 1 minus x, which gives us 1 by 1 minus x plus 2x times 1 minus x by 1 minus x square minus 4 minus 1 is 3, so 3x square by 1 minus x. Now here 1 minus x and 1 of the 1 minus x gets cancelled out. So in the denominator in all these terms, we end up with 1 minus x. So combining all these terms, we get 1 plus 2x minus 3x square. Let's write it in the order of powers of x. We have minus 3x square plus 2x plus 1 divided by 1 minus x. And factoring it, we get 1 minus x times 1 plus 3x divided by 1 minus x. 1 minus x, 1 minus x gets cancelled and we are left with 1 plus 3x, which is what s sub 2 is, the sum of first two terms. So that was Arithmetico-Geometric Series. Now, if you found this session helpful, please do like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. That's it for now.